achieve something with all this effort. So I'll tell a bit about my team, JAM0 Technologies, about the company, a personal story why I'm here, and something about Pyjamaz. It's a bit like the talk I did in Lisbon, but a bit more elaborate. I gave it some more thought and got some nice images with it. This is my team. It's me, Emil, with Peter, Arjan and Matthijs. Arjan and Matthijs were all full-time developers, engineers, in a Python background, economics background, and Peter, he's our CFO for a day, dealing with some of the compliance stuff. So one sheet, a summary of where we come from. We are based in Rotterdam, that's in the Netherlands in Europe. We are a group of university best friends. We've been working together very long, and that's important to me at least, and to the others. We are former Web 2 entrepreneurs from the late 90s, in the cowboy frontier era of web. We all have our success stories from that era. Because of that work, we kind of got a good feel for Ethereum early on, and we followed the mindshare into Polkadot. We founded Polkascan in the early days of Polkadot to get an open source block explorer paid for by the treasury and for the community. There were some successes and some failures, perhaps. Governance is a tricky place to be involved in. Because there was no tooling when we started building Polkascan, we had to build our own tooling. We did that in Python, and that's kind of the artifact we still maintain. Nowadays, all the low-level Python libraries for Scale and for Substrate to interface with that. So if you do anything with Python and Substrate, you're probably using our libraries. Fast forward to 2024, kind of felt with the great paper that all these ideas that we could never keep up with Polkadot are converging on something really, really nice we can work with again. So we are very happy to give it a go to implement JAM in Python. So we got a nice suggestion for a new equation, equation 0. If we sum everything you know about Python and sum everything you know about jamming from A to Z, you get a Python implementation of JAM from A to Z. That's good for a few laughs. Why am I here? It is a bit of a personal story. I can give a 15-second summary or a few minutes. When you talk about Polkadot, it's not really clear what we're talking about. Are we talking about a vision or a mission or a product, as Sean nicely summarizes in one of his recent tweets? I think we are here for the vision, and we're not really sure how it translates to a product, but that's part of the exploration we're doing. I think Polkadot is a vision for a more human-centered digital future, and we are very curious to see how that turns out. And there's no better way to understand something than by helping contribute to something and building it. We are very motivated to do that. We have a team of 3 full-time engineers, and we have nothing better to do. And what I mean with that, we have a full-time commitment for the next 24 months to get the best of Python and get our best understanding of JAM and combine that to see how far we can get. I can tell you a bit about, well, bit of admiration, bromance I have with a number of people. And it's not about Gavin. I can assure you I spend more time on Bruno Latour and I spend more time on Matthew Bellamy, but on average I spend about 10 years on average of studying these people, and there are some similarities. When I was working on a Web 2 platform, built that myself, spent 15 so years on it, in a niche market, personal protective equipment market. I became very aware of the power you have as a platform operator. My economics master based on a thesis on that, and later on I started on a PhD thesis about power and governance of IT platforms and how you can, find all sorts of mitigations for all these risks that arise. That work was mainly based on Bruno Latour's work. He's a French philosopher. He passed away a couple of years ago, unfortunately. Sociologist, anthropologist, and he kind of created a philosophy of how social realities are constructed. And his key insight is to look at agency of systems, and not necessarily at agents, but if you look at the agency of actors in a system, you can let go of who is a human actor and who is a non-human actor. Well, it goes too far to go into that, but as an anthropologist, you basically follow all the agency and draw a network of that. A simple example he uses in one of his early works is in a traffic situation, you have a traffic light or a speed bump. It is technology that is created by humans, but it has the same agency as a traffic police officer standing on the crossroads. So all sorts of interesting philosophical consequences arise. Whose agency is asserted by this technology? Obviously, you can't drive that fast with a speed bump because you will wreck your car. So the impact of the agency of the speed bump is clear, and that kind of works for all material, digital, non-material objects. Then Ethereum happened, and rather than having all sorts of legal constructs, I could actually have a system that could have a more balanced agency between humans and non-humans. Again, it goes too far to get into that. One of my other admirations is the work of Matthew Bellamy, a British musician. You probably know him from the band Muse. Not many people know I played in a Muse tribute band for over 10 years, as a testament to my admiration. Well, there's lots of reasons for that. The themes that are addressed by Muse are the themes of technology, power, surveillance, resistance, human identity, and it discusses some dystopian futures. What happens, or what are the consequences of technology falling in the wrong hands, and I'll get back to that. Well, then there is Gavin. I don't have to explain this, but it captured my attention with his contribution to Ethereum, which is a key contribution, in my honest opinion, with the yellow paper. And I think Gavin's contributions can be brought down to his way of generalizing, abstracting, and institutionalizing the things he has been working on towards a scalable, resilient world computer. So what is in common and what is distinct? I think they are all three multidisciplinary generalists. They have a critique of technology's role in society. there are some examples we can find that they might be a bit misunderstood, but they are very persistent and spend more than a decade, obviously, on exploring these layered ideas. Whereas Latour creates a philosophical foundation that helps us question agency of technology or materiality in our lives and our role in it. Matthew Bellamy gives an emotional, cultural voice of a generation wary of technological control, and I think Gavin gives a real practical implementation of Latour's philosophy towards a more human-centered digital future. So why am I here? There is an ongoing discourse, dialogue on ethics, power, and the potential of the digital or technology in more general. Polkadot, in my opinion, is centered around humanist and liberal values. Technology is not neutral, and I think this is an important point to make, that while we are all building JAM, JAM is not Polkadot, and but JAM can be applied to help Polkadot. Well, we can go into that in a discussion later on maybe. We and my team are very motivated to contribute to helping Polkadot move along. So a bit about Pyjamaz. It's the images you can get from Grok are really excellent. So this is a Python in Pyjamaz for those who didn't notice. Well, there are a number of reasons why we use Python. I can tell a bit about our repositories, about conformance, a testnet that has been discussed with Surab. There has been an ongoing discussion with that, and some considerations we have for achieving milestone 3 and 4. Well, we have 5 reasons not to use Python, and it's performance, 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 and performance. It is an interpreted language, slow execution, dynamically typed, high memory consumption. What's it? This is a Python-esque thing, but there is a global interpreter lock that presents real multi-threading, which is a pain in the ass, and it's not the best language to do all this sort of low-level stuffing. But we are a bit stubborn, mostly because of sunk cost, because we spend most of our lives on Python, and we maintain and build the Python substrate ecosystem, but there are a number of additional good reasons. It is an easy to use and readable language, and I think that's important to have it in the mix of languages that are available for implementers. I liked what the Fluffy Labs team has been doing on their website. They are very aware, I guess, like us, that they will never create the most performant implementation, but that said, their mission is kind of to make it the most useful implementation for other teams. So I'm not really ready to discuss what our contribution will be, but it might be something along those lines. It has lots of tooling and components available. It works everywhere. I think an important point to make is first off, for multiple domains, so machine learning, even AI or data extraction or scripting, it's used a lot for that in academic spheres, and it has a very widespread popularity. I'll get a bit more into these trade-offs later. We have a number of private repositories at this point. We have the Pyjamaz application, which is the node. We have the PVM, the JAM codec, and a number of foreign function imports, basically Python wrappers around Rust libraries, and the snatch erasure coding. BLS, we haven't really started on that, and we'll probably do an additional wrapper for the quick library, because the Python native instance, it works for 98%, and it's just not worth the effort at this point to invest your time in something that you have some doubts about. Well, we also maintain a number of Python bindings and libraries that fall under Polkadot. One announcement I can make is that we'll probably end Polkadot Foundation and move these libraries over to JAM0, just to have a single place to maintain these things. But like the skill codec, the substrate interface, the Edwards libraries, and the Snorkel cryptographic library, which isn't used for JAM in particular. Well, I can tell you a bit about test vectors and our own unit tests. We have been implementing all the published test vectors, which have been merged to main by Web3 Foundation, and all the tentative test vectors. So we support all these vectors in our implementation at this point, and we have some additional unit tests that cover the stuff that either hasn't been covered yet or won't be covered, which is implementation specific. But we are trying to keep up with everything we do with our documentation, MK docs, simple list of the state transition functions, still based on the 0.3.8 version, I believe. This is an interesting one. Assurances have 3 state transition functions with the intermediate functions. It gives an idea without giving too much away about the code. We have implemented a command line interface. We've been working for a very long time with all these substrate chains when we were working on the Polkadot, so we got our inspiration from there. And if it works, well, you don't have to reinvent everything. A very nice and neat little feature that Arjan implemented last week is the culprit mode, which allows your node to be malicious intentionally by spamming or whatever you can do to well, confuse your fellow nodes. This is work in progress. The CLI has a debug mode, so you can explore all your nice little Python objects from the command line. And this gets us a bit to the work that Colorful Notion has initiated with at least having a discussion about how can we have a cross-chain multi-client testnet. So as you can see, this is already Dockerized. It already has, I think, a port 9000. So we started implementing the network protocol, at least CE 128, for requesting blocks. But at the moment, we are simply listening to a shared Docker volume to exchange blocks, which is a very practical way to have a working multi-client Python network without any networking components. Baby Python in Pyjamaz, with Polkadot Pyjamaz. Grok does everything for you. A multi-client, multi-node, 6-node tiny network of Python clients all working well. This does not yet implement several incomplete, although we have it done. Some additional networking is required to exchange tickets for several, and if you create a ticket, you're not usually the block producer of, so someone else needs to include the ticket. So when we implemented this, we actually found out that the network actually works because you have this fallback mechanism that if there is no tickets, it keeps on chugging along. So that's a very nice way of finding out how JAM is supposed to work, I suppose. So what we want to achieve, and again credits to Grok, we want a multi-client testnet. So Python, the Gopher mascot, and the Rust crab, and Grok has some difficulty in adding non-animal mascots in a similar picture, so I quit my efforts after spending 3 hours on this. Okay, but what do we want to achieve? We want these 3 little happy animals, or potentially 10 little animals, to play with blocks and to create a JAM chain. So again, performance will probably be a challenge for Python. We kind of made a conscious choice to be opinionated about the Python version we are going to use. While we started supporting all the major versions of Python, we kind of got a good feel that we probably need to go for Python 3.13, which is a very recent release. Like I said, there's lots of mindshare from the machine learning applications of Python, and there's a real push for performance in Python. That's an ongoing discourse, like removing that global interpreter lock, like having Python compile to binaries. So I don't know what we can achieve, but it is ongoing, and I hope we can reach Kusama level performance, whatever that means, because that's an interesting follow-up question I have for later. How do we determine in objectives or relative terms what these performance benchmarks should be? So this is my presentation, and I hope the pizza will be here soon. Thank you. Oh.